All right, so this is the Unit 12A handout. So it's our Intro to 3D Geometry. So before we jump right into stuff like in number 2, those 3D diagrams, let's talk about the term lateral. So you might have heard of like lateral movement or latitude lines on a globe. Um, Maybe you've heard of a lateral pass in football, which in football, lateral pass actually means two things. It means a backwards pass or a sideways pass. Only one of those actually has to do with the word lateral. So here, let's think about latitude lines on a globe. So I have a globe up here. These lines going up and down are the longitudinal lines. The latitudinal ones are the ones going around the side of the globe like this. Right, so it's going from side to side around the globe. So those are latitudinal lines. The Latissimus Dorsi, that's a muscle in your back that stretches all the way from one side of your back all the way around to the other side of your back. So, and lateral movement is sideways movement. So I feel like you hear about lateral movement a lot in football and in basketball, but I don't know, maybe other sports too. So lateral refers to sides, sideways, stuff like that. Okay, so sides is the way that we're going to think about it. All right. So not top, not bottom, but sides. Okay, so number 2, you may have heard of a prism as like that thing that breaks up light into a rainbow, but it's different from prisms that we're talking about in math. So in math, a prism is a 3D figure that has a polygon for a base, and then you duplicate it, so you have a congruent polygon for a base, and then you line them up and you connect them all with these straight segments right there. Right? So you end up with a bunch of sides, a top and a bottom, or two bases and a bunch of sides. So it's a right prism. We're going to label these diagrams, by the way. So it's a right prism if the sides are perpendicular to the bases. So notice on the right here, this side right there, that does not form a right angle with the ground. That's slanted, right? It's got a slant here, so it's not 90 degrees. If it does form a right angle with the ground, then it's called a right prism. So this one, I tried to make it so that these angles look like they form 90 degrees with the ground there, right? Hopefully you can tell that that's what I was intending. So this one is the right prism. And the one over here, when it's slanted, then you just call it an oblique prism. By the way, since this purplish one, has a hexagon for the base, you can actually call it a hexagonal right prism. This one, if this were like a rectangle down here, then I could call it a rectangular oblique prism. Okay. So let's label, we've labeled right prism, we've labeled oblique prism. Let's label some bases. So a base is just the entire polygon that forms either the bottom or the top, but not the sides. So in this case, this would be a base. And the top would also be a base. And over here we got a couple of bases too, these parallelograms or rectangles, whatever they happen to be. Okay, so we got base. Base edges are what they just sound like. They're the edges of the base. So base edges would be things like these guys. Base edge. This one would have 4 base edges going around here. Base edge. And it's just the edge of the base. There would be base edges up here too. So these are base edges. Right. So you get the idea. Lateral face. Okay, so remember lateral sides, right? So lateral faces are the sides of the thing. So I'll highlight a couple here, like this one. That right there would be a lateral face. Or the one in the back here, that would be a lateral face. So there are a bunch of them, right? So here, I'll just label this one here. So this guy right there is a lateral face, a side of the entire shape. I'll do the same thing on this side too. So this one right here, if I highlight this guy, I didn't do that very well, but you get the idea. This is a lateral face. So we got that taken care of. Lateral edge. Well, that's the edges that are going up and down, connecting the bases. Right. So let me use a different color. So these things right here would be lateral edges. This one is not a lateral edge. Even though it's part of the side, base edge wins out. If it's part of the base, it's a base edge. So over here, we've got some lateral edges too. So these guys would be lateral edges. Right. So this one would have 4 because you've got the one in the back and the one over here too. So lateral edge. Then altitude. Well, since this thing is perpendicular to the ground, it goes straight up and down. This is its altitude. The lateral edges are the same thing as the altitude. So let me do this. Also altitude. For the right prism, right? These guys are the same. But over here, these are slanted, so that is not the altitude. The altitude would be this thing right here. Just whatever that height is right there, from top to bottom. So this right here, let me draw it over here. I'll do it here. This right here is the altitude. And then let me separate these two. Okay. All right, so let's move on. Okay, lots of terms there. If you have something that looks like a prism, but instead of a polygon for the bases, you've got circles for the bases, or ellipses, ovals, right? Then you call it a cylinder instead of a prism. By the way, we're only going to use circular cylinders, so don't ever worry that if I draw one that it's not a circle. Okay, so a few terms. We've got a term called lateral area, which I'm going to abbreviate LA. Lateral area just means areas of the sides, right? So area of the sides. I'll write that here. Area of sides. Total area is what it sounds like. It's the area of the sides plus the bases, right? So like in this one, lateral area would require, so it's just the sides, it'd be one face here, one face here, one face there, one in the back, one more in the back, one more in the back. That'd be 6 total. So, whereas total area, you'd have to add up the 6 faces, 1, 2, 3, 4, 5 in the back, 6 on the side there, and then 7 for the top and 8 for the bottom, right? Let's see. So that's total area. That's this guy. And then volume, right here. Volume, the way that you get that is you find the area of the base. So let's say your base looks like this, right? I realize that looks weird, but let's say that's your base. So you find its area, and you've got this 3D looking shape here where the top is identical to the bottom. So let's say that this area in the bottom was 100 and that the height was 5. Then the volume of this thing, if I multiply by the 5, it's kind of like I take the 100 and I sort of fill it in all the way up to the top. And if you fill it all the way in up to the top, then you end up with 500 units of volume. So it's just the area of the base times the height. Right? That's how you always get the volume of either a cylinder or a prism. All right, so let's see, what's this say? Using the hexagonal prism from number 2, so that's this one. How many individual areas would you need to add up in order to find the lateral area? Okay, remember lateral area means area of the sides. So, well, how many side faces are there? There were 6 side faces. There's this one right here. There's this one right here in the front. There's this one right here on the side. There's the one in the back right there. There's this one right here, and there's this one right here. Now, it's much easier to count them if you just do this. Look, each one of these has a face coming out of it. Whoop. So there's 1, 2, 3, 4, 5, 6 faces all coming up out of those sides. So 6 for lateral area. Lateral area equals area of 6 sides. To find the total area, well, that would be the lateral area. That's all 6 sides. Area of 6 sides plus area of the 2 bases. Right, the top and the bottom. So this one would be 8 total areas. So this one requires 8. This one requires 6. Just for this example, right? What would the units of lateral area be? Well, lateral area is, let's see, if we were working in meters, well, lateral area is an area. Area is in meters squared then. And total area, well, that's still an area too, so that would also be in meters squared. Volume. So volume, remember we said volume is the area of the base times the height. So it's area of the base times the height of the prism, right? Or cylinder. So area of the base, area would be in meters squared. Height would be in meters. So if you multiply meters by meters squared, you're going to get meters cubed. So volume will be in units cubed, and the areas will be in meters squared. Okay. That's if the original's in meters. So let's go on. Number 4. Find the lateral area, total area, and volume of this hexagonal prism right here. And in this case, the hexagons are regular hexagons. Sides are all 10 inches. And then this right here, this one down here, is just this drawn by itself so you can work on it. Okay. So that means that these guys are 10 centimeters going around here. 10, 10, etc. Okay, so let's see. What do we need? Well, let's find the lateral area. So lateral area, which remember lateral means area. Lateral means sides, so it's area of the sides. So the hexagons are the bases. These things, these walls here, like that one, those are the sides. So I got one there, one on the bottom. So there are a whole bunch of them. And there should be 6 of them, because one for every side of the base. Right? And they're all congruent to each other. Like this rectangle right here is going to be 10 times 15. Right? This rectangle right here, that's another 10 times 15. So the lateral area is going to be 10 times 15 for one rectangle, plus another one, plus another one. Well, there are 6 of them. So it's going to be this, 10 times 15 times 6. So that's 150 times 6. What is that, 900? Yeah, 900. Okay, we're working in inches. Whoops, not centimeters, inches. So since it's an area, it's going to be in inches squared. 900 inches squared. Okay, next thing we want is going to be total area. The total area is going to be all the sides, plus the front in this case, plus the back. Right? So we need the front and the back. So let's get the area of the hexagon. Right? And then we can double that. So, okay. So it's a regular hexagon. We learned in the last couple units now how to cut this up. So you don't actually have to draw all 6 triangles, but you can. So there they are. And then one angle of it, one central angle, well, all the way around 360, so one of them is 360 divided by 6, 60 degrees. So these are all 60 going around here. And then let's cut it down the middle so we can get the, oh wait, actually I already know the base is 10, so that gets cut into 5 and 5. We just need the height then, x. And this gets cut into 30 and 30. So that means that we're looking at a 30, 60, 90 triangle right here. So let's use that idea. 30, 60, 90. We've got the 5, we want the x. And then if I draw the basic 30, 60, 90, short side is 1, medium side is root 3, long side is 2. So the 5 goes with 1. The same way the x goes with root 3, which means x is going to equal, x times 1 is 5 root 3. Okay, so the height here is 5 root 3. So then the area of this one triangle, right, so the area of the triangle is 1/2 base height, 1/2 10 for the base, 5 root 3 for the height. So it's half of 50 root 3, which is going to be 25 root 3. So that's the area of one triangle. So then the area of the hexagon is 6 of these triangles. So that'll be 6 quarters would be $1.50, so 150 root 3. So then that's the area of this face right here would be 150 root 3. The area of the back face back here would be 150 root 3. So then if I add that to the area of the sides, which was 900, the total area is going to be, first I'll write it like this, the lateral area plus the area of the bases. So that was 900 plus 150 root 3 times 2, because there's the front and the back. Right? So then that's going to be 900 plus 2 times 150, 300 root 3s. So let's go ahead and record that. So total area, 900 plus 300 root 3, and since it's an area, it's square inches. So let me shrink this stuff down just a little bit. Okay, so let's do volume. All right, so volume for a prism is always going to be the area of the base times the height of the prism. So it's like taking this one base, and then when you multiply it by 15, you essentially fill in this whole thing all the way up to the top, including the inside. You just fill everything up all the way to the top. Okay, so we're going to take that 150 root 3, the area of the base, the area of the hexagon, and multiply it by the height of the prism, which is actually the length, really. It's just you got a picture, you turn this thing sideways. So times 15. So 150, if you have 150 root 3s and then you multiply that by 15, you're going to end up with 2,250 root 3s. And then it's a volume. The area of the base is inches squared. The height of the prism is inches, so we get inches cubed. 2,250 root 3 cubic inches. Okay? And then let's take a look at 5. Last problem. So lateral area and total area of this slice of a cylinder, right? A big slice of a cylinder. So notice down here, there's a right angle. This is the overhead view, by the way. This is the view of the top right here. So notice that angle is 90 degrees. So this is 90 right there. Or you could think of it as this is the actual sector that we're looking at is 270. So this is 270. Okay. Now, before we jump into this problem, I want to review two things that are related to sectors. So one of them is area of a sector. So remember, that's theta over 360. It's a fraction of the circle's area. So there's my fraction of the circle's area. And then there's another one that's arc length, which is a fraction, but not of the area. Instead, it's a fraction of the total distance around the circle, 2 pi r. Okay? So this I'm just going to kind of put in a bubble and turn a cloud, and we'll come back to it. Okay. So let's see. Lateral area. So lateral area is area of the sides. Okay, well, two of these areas shouldn't be too bad. That's this rectangle right here and this rectangle right there. Right? Now the radius is 5. Excuse me. So this is also 5. So really the area of this rectangle right here is going to be 5 times 15. And that because the height's 15 over here. And then this one's also going to be 5 times 15. So those rectangles are easy, right? But you also have this curved wall right here that goes all the way around the back and then back around to this side. So that we need. And that's not as easy to picture how to get the area of that thing. But you might be able to imagine that if I took this curved wall here, so if I take that curved wall and I kind of like unfold it like it had a wrapper around it, and I took the wrapper off and unfolded it. So right now the wrapper would look like this. Okay, can you kind of see that? How that's the wrapper that goes around this thing, right? And if I unfolded it and flattened it out, so I'm going to say unfold and flatten, then you end up with a rectangle here. Okay, now let me note, this point is A, this point is B, here's A, here's B, and when you unfold the thing, here's A, and here's B, right? Well, I know that the height is 15. This is 15, so this is 15. The length of the rectangle I need, right? I need this thing. Well, let me highlight that. Let me, what's a color I can easily use here? I'll use this green highlighter. This thing right here is this part of the curve right there, which is this part of the curve in the main diagram, which is this part of the curve in the overhead view, right? That direct view of the base. Well, I can figure out what that is because I know the arc length formula, right? I need how long that arc length is. I'm going to call that L. So I know that L equals the central angle, 270, at a 360, and it's a length, not an area. So I want to get a fraction of the circumference, right? 2 pi r. Well, r is 5. 2 pi times 5. So if I work that out, that comes out to be 7. Let's see, do we want to do exact form? No, I'll spare you from exact form for this problem. So let's just do, let me call up the calculator here. Oop. All right, that's fine too. So 270 over 360 times 2 pi 5. All right, so it's 23.56194. Okay, so there's L. Well, that means that the area of the curved wall here is, remember, that's the area of this rectangle. That's 15 times L. So the area of the curved wall equals 15 times L. So it's 15 times that 23. So multiply that 23 times 15, and we get 353.42917. So there's the area of the curved wall. And then remember, if I want the total lateral area, I got to add in these rectangles here, this one and this one. So the lateral area equals the area of the rectangles. I'll write it like that. The two rectangles plus the area of the curved wall. And then 5 times 15 is 75. So it's going to be 75 plus 75 plus the 353. And so if I add 75 plus 75, we get 503.429. 503.429. Let's see, do we have units for this? Yeah, since we're working in centimeters, area is going to be centimeters squared. Now, I have it in exact form too. In exact form, this is 150 plus 112.5 pi. So let me check that just to make sure. 150 plus 112.5. Whoops. Pi. Okay, good. That's right. Okay, let's do total area. So total area, let me use a different color. Total area is going to be the walls, so the lateral area, plus the area of the top, plus the area of the bottom, which are two of these sectors here, right? Well, the area of the top and the bottom, those are sectors. So I know the formula for the area of a sector. So area of the top equals the same thing as the area of the bottom, which equals the formula for area of a sector right there. Central angle, 270 out of 360. So it's a fraction of the circle's area, pi 5 squared. So if we punch that in, let's see, 270 divided by 360 times pi 5 squared, we get 58.90486. And let's see, so we've got two of them, and we've got the lateral area. So total area is going to be well, let's do it in the same order that I wrote it here. Lateral area first, 503.429 plus, and then two of the top, or one top, one bottom, but it's 2 times 58.90486. So let's figure out what that is. So there's the 503 plus 2 times 58, and we get 621.239. And that's going to be, since it's an area, it's also centimeters squared. In exact form, it's 150 plus 150 pi. And we can check that just to make sure. Sweet. All right. Okay. I know that's a lot to digest, but hopefully it made sense. The homework tonight, I think it's 6 problems, but you can choose any 5 that you want to solve, and they're not necessarily in order of difficulty. So choose wisely. All right. I'll talk to you guys soon.